Hello students, we're back continuing our lectures on quadratic equations. So we did a little introduction to general quadratic equations and functions, their nature, and we summarized the main ways of solving quadratic equations, which is through factoring, square root property, completing the square in the quadratic equation. We reviewed how to solve quadratic equations via factoring in the last lecture, and what we're going to tackle today is solving using this square root property, which is a real convenient way to solve quadratics when it's set up. So, solving via the square root property, what we have to note is that we are looking for a certain setup to be able to apply the square root property. Otherwise, it doesn't work so well. So note, to apply the square root property, to solve what we want in a certain form, certain format. Okay? Otherwise, we have to apply different techniques like completing the square or the quadratic equation. So we wanted a certain format. So we're going to go over here. This is nonlinear board. Remember, we're taking off from linear equations. We're going to curved spaces. So we have a certain form that we want. So our goal is to solve something that is in the form where you have a quantity squared equal to some number. Okay? And it's all right if we have a coefficient. We can have a number here too. It doesn't matter. So we can have something there. But this is the format that we want. And when we see quadratic equations set up in this format, then it makes it really easy to solve them. So some examples of these will be coming up shortly, but the idea is just to take the square root of both sides to solve. It makes it nice. Okay. So some examples. That you can apply the square root property right off are, number one, let's say I had x squared equals 49. Well, this is a real simple one. We could just take the square root of both sides. And we get x equals plus or minus 7. Okay? That's one that you can apply right off. I solved this one too. I took it a little step further. But other equations where you could apply the square root property, is you see it in this sort of format, x minus 1 squared equals, let's say, 16. I could just take the square roots of both sides and solve it. So let's go ahead and apply that to some equations that exhibit this setup, this format. Okay. And shortly after solving the square via the square root property, we will tackle completing the square, which is a technique that allows you to get the same format. So we do have another step involved today as well with this material. Okay, so let's go ahead and look at some of these. Directions, as usual, we'll say solve. That's the main type of direction you'll see. They might say solve the quadratic or solve by completing the square or solve by factoring. So when directions specify the technique, make sure you're paying attention to that. So in this case, let's go ahead and start with just something very simple. Let's say we have x squared minus 2 equals 16. I'm going to change this. Let me make this into a 14 for now. Excuse me. So if I have x squared minus 2 equals 14, does it follow the format? Well, it doesn't quite look like the format right off, not like the last example I showed you, but I realize I only have an x squared term, and I have a number term. And the question I'm asking myself, can I just get a squared equal to a number out of this? Yes, very possible. All I have to do is move that 2 over, or technically add 2 to both sides. And so in this case, if I do that, I end up with x squared equals 16. I have my variable quantity squared, my number quantity, and I just go ahead and take the square root of both sides. So I take the square root of this side, and I take the square root of this side. But when you take the square root on this side, you have to know, when you take the square, you have to make sure you insert a plus or minus. So note, when you square root your number, note you will have positive and negative roots or values. Okay? Because the question, what we're looking for here is we want to find out what we could square when we subtract will produce a 14. Well, there's a negative and a positive combination. So when we're reversing that square by square rooting it, we have to remember that there's 2 ways to make a 16. That is by having a positive 4 squared, and by having a negative 4 squared. And that would be our final solution. If you check, we know it works. So 4 squared minus 2 is 16 minus 2, which is 14, and that works. And minus 4 squared, which is 16 minus 2, is also 14, and that works. All right, so moving along, we might have some other types of problems, like a little bit more here. Whoa. I'm going to make it a little easy on this first to start with. Okay, let's try with the 36. What I want to do in this case is I want to square root both sides. So if I take the square root of this side, and the square root of this side, I should get my values. So the idea is, what I'm identifying here is I have a quantity. Get better. Here I have my quantity squared, so I could just square root it to undo it. So all this is together is one quantity, and then on this side I have my number. So I just want to go ahead and take the square root of both sides. I could do that directly because I have no other terms that I'm adding or subtracting to both sides. So this is in the square root property format. So I can directly square root right away. So my solutions then will be x minus 2 equals positive or negative. Luckily for me, 36 is a perfect square. So the roots of 36 are positive and negative 6. And then this is not how I typically do my solutions. I want to say x equals. Like if you're saying your variable is equal to a certain number, you don't want to give a sentence for that number. You want to simplify always. So this means that x equals, I add 2 to both sides, but I add out in front. This becomes, x is going to be 2 plus 6, and x is going to be 2 minus 6. So this becomes 2 plus or minus 6, and what we get out of this is x equals 2 plus 6, x equals 2 minus 6, And my two solutions, remember you have up to two solutions for quadratics. I get x equals 8 and x equals negative 4. Bingo. All right, so what if we add a little bit more here? What if we all of a sudden go ahead and put a 2 out in front? So we get, let's say, actually, I'm going to do 4. Let's say we have 4 times x minus 2 squared equals 36. All right, so we're adding a little extra work here, but not a big deal. I could still square root it and square root it. But what I want to do is, first of all, identify that I can use the square root property, but I also note that I could just divide out both sides by 4. So in this case, what I'm going to do is divide first. So I'm going to divide by that 4 first. So I'm going to rewrite this to make it easier to apply my square root property by dividing both sides by 4 and then working with what I have left over. So now that I got my coefficient, my second step would be to go ahead and take the square root of both sides. So I'm going to take the square root of this side, and then I'm going to take the square root of this side, and that's going to be a plus or minus root, and I end up with x minus 2 equals plus or minus 3. So again, this is my little way of dealing with these two different solutions. I'm going to end up with 2 different solutions here. Divide this up on the board. I end up with x minus 2 equals positive 3 and x minus 2 equals negative 3. So that my 2 solutions will be x equals 5 and x equals negative 1. And those are my solutions in this case. So we had to do a little bit more work to get directly to square rooting it. Okay, so some other cases that come up. You don't always get perfect roots. Some things are not nice. Let's go ahead and take a look at a fraction. And some other not so nice roots. Okay, let's go ahead and add, there's another problem. Let's say we had x minus 1/2 squared is equal to, I'm taking some material out of worksheets, 25 over 4. Okay, and messy fractions. And just a note here, I know everyone loves to work with fractions, so hence we'll go ahead and attempt one here. We look at this and we see that it's in the square root format. We have our quantity squared, our number right here. Main thing is to take the square root of both, which we could do right away. We don't have to divide by anything or add or subtract numbers. We have our quantity right here. So remember, if you're adding or subtracting values, you go ahead and bring them over to your number side. So this is equal to 25 over 4, and I'm going to square root this, and that's a positive negative root value I get. So this cancels out the square directly, and I get x minus 1/2 is equal to. Now here's a root of a fraction. This is the same thing as saying the positive and negative root of the square root of 25 over the square root of 4. Okay. So going a little further here, I have x minus 1/2, already in the same way I have my roots here, is equal to positive and negative 5 over 2. So lucky for me, these are both perfect squares, and I'm not left with a radical in the denominator that I have to rationalize. So remember those rules. And then I could further simplify my answer as x minus 1 equals positive 5/2. I'm going to make myself a little more room. x minus 1/2 equals positive 5/2, and x minus 1/2 equals negative 5/2. All right, I wrote my 1/2 a little differently in both cases, but it's good brain exercise. Next step here is I have to add fractions. So lucky for me, they're common denominators, and I have x equals 1/2 goes out in front here, and I'm going to add 1/2 plus 5/2, or it doesn't matter as long as you're adding it correctly and keeping track of your signs. So this becomes x equals 1 plus 5 over 2, same denominator, 6 over 2, and finally I get x equals 3 out of all that. So it's a lot of work just to get that solution, but such is life. It's a lot easier than doing the quadratic formula, as we'll see on a problem like this. In this case, we get x equals 1/2 minus 5/2 when I bring that 1/2 over. And the next step is x equals 1 minus 5, which is minus 4 over 2, which is the same as negative 4 over 2, which is the same as 4 over negative 2. 3 ways of saying a negative there. And I get x equals negative 2 out of all that. And these are my solutions. And again, if I claim these are my solutions, I should be able to plug them back into the variable of x. So I put my 3 in here, subtract half, get 2.5, square it, and get 25 over 4. And the same goes with the minus 2. So if you claim it's your solution, you can always verify it with a check. So of course, things could get rather complicated and not always nice. So let's go ahead and look at another one. Let's see. I'm trying to think of something that might be a little trickier. Let's go ahead and do a problem like 2x minus 1 and let's say I have a 2 and then minus 3 equals, let's see, what's a good number? 15. 17. We're going to make this a little more of a challenge. All right, so if you have a problem like this, there's a lot of little details you got to attend to first before you could just directly take the square root. So in this case, what I would do is, doing my step-by-step numbers, I would add 3 to both sides, and then I would divide by 2. So here I have 2, it's 2x minus 1 minus 3 equals 17. So I'm going to add 3 to both sides. Bring this over first, and then I get equal to 20. Next step I want to do is divide both sides by 2. Okay. And then what I end up with, oops, I missed putting a square here. Sorry, it's not a linear equation, it should be a square, so oops there. So change your original problem to 2x minus 1 quantity squared. Otherwise, we'll defeat our purpose of using the square root property. Now I want to divide both sides by 2, and then I have 2x minus 1 quantity squared equals 10. And the question is, how do I solve this now? Well, what we do is we finally take the square root of both sides. Square root this, square root this, and I get 2x minus 1 equals plus or minus the square root of 10. And then I have 2x equals 1 plus or minus the square root of 10. And then finally what I have to do is divide both sides by 2. Now this is not a nice number by all means. What you see here is, and again I'm going to have to write my solutions here, you see that you get x equals 1 plus the square root of 10 over 2. Now, this is a root that cannot be simplified. So going back to the material we did on radicals, the square root of 10, the most precise way of representing the square root of 10 is just the square root of 10. We can approximate it as a decimal. And if you notice, the square root of 9 is 3. 10 is just a little above, so this should be 3 point something. So we have 1 plus 3 point something divided by 2. So we have about 4 point something divided by 2. And then here we have 1 minus the square root of 10. So 1 minus about 3 point something divided by 2. So my other solution is x equals 1 minus the square root of 10 over 2. However, if you run out of paper space, or you just don't like having to repeat things, you could just concisely represent your solution as 1 plus or minus the square root of 10 over 2. So either is sufficient. So here's your solutions to this problem. Is this, and this, and this all together. Okay. So what we have here is our solution to our problem. And they could get a lot more messy, as we'll see. Let's add another one. Let's say I have. Add a little twist and turn here. Okay, so let's go ahead and solve the 6th problem here. And let me see, I'm going to go ahead and do, don't forget my square this time, 2, and then I'm going to subtract maybe 1 and have this equal to what I want to add here is 6. Okay. So a few tricks along the way. This is very similar to what we had earlier. And in fact, I don't want to have 6. Excuse me for a second. I want to have 20. 6, let's see if this one works. Hang on a minute. I should be looking at my notes to get a better problem instead of trying to come up with it here on the board. But this will work. Let's go ahead and make this 23. Okay, and we'll see. We'll just deal with what we have. If it's not nice, sometimes we get ugly problems. They're not always prefabricated to be nice quadratics we have to work with. In real life, when we're doing applications, they get messy. So let's take a look at this. To start with, we're going to do the same process. We want to get our number squared, and our quantity squared here with our variable. And here we're going to go ahead and add our 1 to both sides so that we have 24. Okay. Then I'll notice that I want to divide out that 2 to keep it simple. So I just have my whole quantity squared all together without any coefficients. And now I have 2x minus 1 quantity squared equals 12. And again, I want to apply the square root property. To this quantity. So I have 2x minus 1 quantity squared equals 12. And I'm going to go ahead and take the square root of both sides. And I'm left with 2x minus 1 equals plus or minus the root of the square root of 12. Now notice 12 is not a perfect square. So what do I do next here? I'm going to take an extra step and I'm going to say, well, before I do anything else, what I want to make sure of is I simplify any roots that can be simplified. Let me extract any roots that are perfect squared in this 12. So I'm going to break this 12 into 4 times 3. This is where all our skills done previously will come into play. And my root now becomes I take the square root of 4 out. I could take the square root of the 4 part, which becomes 2. The 3 is left over on the inside, so this becomes 2 square roots of 3. Now what I want to do is go ahead and bring my 1 over to the other side. If I end up with 2x equals 1 plus or minus 2 square roots of 3 from bringing that 1 over or adding 1 to both sides. And my last step is to say 2x equals 1 plus or minus 2 square roots of 3. My last step is to divide out both sides by 2 so that my final solution is x equals 1 plus or minus 2 square roots of 3 over 2. A lot of writing. Okay. But the important part in doing these type of problems is not to skip steps if you're finding yourself making mistakes. The more you try to rush it and skip steps, the more likely you are to make a mistake. At least that's what I find when I grade exams and quizzes on this material. So looking back at my work, I'm kind of going through, making sure I did everything. I see that this is the most concise answer, and I look at this and I always ask myself my last step, can I simplify this further? Just as before. So I'm looking at this, I'm looking at all my terms. Now I could, if there was a 2 or a 4 here, if I had an excess factor of 2, I could divide that out. But as is, I've went ahead and simplified my radical. That's as simple as can be. And all my other terms are as simple as can be. So this would be my final answer. Okay. Now, if we tweak this just a little bit more, and let me go ahead and put make a new problem here. I'm going to change one aspect for you, and we'll make problem number 7. And what I'm going to do is make this a 4. And there are other types of problems where these will come up, but I might just change that one aspect for now. Let's see how would you approach this differently. We have a 2x minus 4 quantity squared. Well, if you were to do a problem like this, you'd approach it the same way. You'd say, I'd want to apply my square root property to solve. So I'd go ahead and bring my 1 over, and I get 24. All these steps will be the same. I'll divide both sides by 2. And I'll have 2x minus 4 quantity squared divided by, this divides out, so these cancel, and I'd have 12 on this side. And then over here, I'm going to have this quantity squared equals number squared, where I could directly apply my square root property. So here I have this quantity that I want to take the square root of and undo the square so that I produce what's on the inside. And here I'm going to take the square root of 12, which produces plus and minus roots. Now my solution will be 2x minus 4 equals plus or minus the square root of 12. Again, same steps. I want to simplify that 12, so we already know from the previous step this is 4 times 3, and the square root of 4 is 2, so this becomes 2 square root of 3. And next, I go ahead and add the 4 out in front. And in this problem, your last step will be 2x equals 4 plus or minus 2 square root of 3. It's to divide out by 2. So you want to solve for a single 1x to the first power, And now our final solution is 4 plus or minus 2 square roots of 3 over 2. And you want to ask yourself, is this as far as I can go? Well, no in this case, because I can see that each has an extra factor of 2. And that might have been apparent here at the beginning because this wasn't factored completely. Okay, but we don't want to factor it because it's inside a quantity squared. But here we're going to end up with those excess factors. And what I want to do is divide each term by 2. So we have this term, and this term. So you can't just divide out these 2 or these 2. You have to divide them from each piece. So I could see that I could reduce this. So the idea is to simplify. Reduce. We can do that. So we're going to do that by dividing this by 2, dividing this by 2, dividing this by 2. And our result will be x equals 2 plus or minus square root of 3 over 1, or more simply, 2 plus or minus the square root of 3. And that's it. Okay, that's our final step. So I'm going to do one little closing statement on the completing the square. I thought perhaps we might be able to tackle that, but we'll leave that for the next segment. So here we want to kind of preview what's coming up next. So next, we're going to look at this topic of completing, solving via completing the square. Completing the square is a technique that applies to more than just solving. So next, in our next video, we'll do this method. But here's just a preview. And we've had nice quantities squared so far, but if you had to solve, you had something like x squared, let's say minus 6x, and let's say you had plus 8 equals 0. I said minus 8. Okay. Well, the problem is we have this minus 6x quantity, right? If we were to move everything over, we would have 6x plus 8, and then we can't just go ahead and take the square root. We can take the square root of this side nicely with the square root here. That's not going to work, okay? So we can't apply the square root property. Directly. But we can make this into an equation for which you can. Now I'm going to show you just the wrap up of this. What happens when we complete the square is I have my ax squared and bx term. I bring my c term over and I leave a little space. And I come up with a combination here that will make this a perfect quantity square. There's a little technique involved, and you might be able to figure out how I produce this positive 9, which is the number I add to complete the square. And I'll do the same on this side so that I have this value. I've made this into a special quadratic equation on this side without incorporating this number, so that I could go ahead and factor it into the exact same factors. So this becomes x minus 3 quantity squared equals 17, and that's the exact same original equation, but now with this equation I could apply the square root property. So the next video lecture will be on how we produce something that in which we could apply the square root property. So that hopefully that's a little brain warm up for the next session, and please practice all the square root properties. There's a good variety out there, and a lot of messy radicals can come up. Thank you, and we'll see you next lecture.